Hey guys. So I haven't done a lot of preparation for today's stream. I've done a little bit of, I guess, setting up some tools. But I found this driving simulator, and it's something that I'm interested in, autonomous driving. And I've even gone so far as to install sensors on my car. But this seems like a much safer approach, using this open source autonomous driving platform to train a AI model to drive this vehicle. Now I'm driving it right now. It comes with some scripts as examples. And the script that I'm running right now is the actual just manual control. So I don't have, I guess, I don't have my own model for autonomous driving. Let me go ahead and switch over here. So I can spawn several different vehicles in the world. And I can manually control either one, or I can set them to autopilot. So right now I have, what is this, like a Monte Carlo or something? I also have a Wrangler, and it's currently on autopilot. I'm not controlling this one. It'll stop for red lights. It'll navigate the world as you would expect. there is some times where it will just crash. Uh, it says something about, he's saying my mic is too quiet. Well, I'm sorry about my mic being too quiet. Is it that the music's too loud? I can turn the music off. But yeah, I'm sorry, I can't do much for the microphone. Maybe I'll get a better one later. But basically, what I want to accomplish tonight is setting up a program that can actually read from a sensor on the vehicle. Because I plan on using the same APIs that this uses for the sensors on a real vehicle. And I don't know exactly how to do this other than through their Python API. There is a C++ API too. But I'm going to start out with the Python API because I think it's going to be a lot easier. So I'm going to park my, I think this is Monte Carlo. Oh, it's an Impala. Okay. I'm sorry. It's an Impala. And I'm just going to let this Wrangler keep doing what it does. And we're going to look at the documentation. So this is the website for them. I'm not going to show you how to install them because if you do any search for CARLA, all the videos and tutorials are basically just how to install the thing. So I'm not going to recap that. I got it installed. It's working. It does crash a little bit. It's a little clunky to get it going, but once you do get it going and it's not crashing on you, it seems like it's a pretty robust piece of software. It's built on the Unreal Engine. So yeah, let me look at the documentation here. So here it's basically talking about the core concepts, and what this is trying to, I guess, explain is that there's the world, which that's what my starting screen was. So if I switch back over to this screen, this is the world. So when you start up CARLA, this is what you see, and there's no vehicles in it when you first start it up. But I've added some vehicles into it, and I can fly around. I mean, this is kind of just a free-floating camera, and we can fly around and maybe go find that Jeep Wrangler that was driving around. So let me go up here, see if we can find it. So that car in that roundabout over there that's just been stuck there, that one, I had it autonomously driving, and it just crashed, like the program crashed. So that car's just sitting there now. Anyway, there's our Wrangler. It's just driving autonomously, which is pretty cool. I can add a bunch of, I guess what you would call NPCs. I wouldn't call them AIs because they are actually hooked into the engine, so they know about the paths and routes and things. So they're just doing like a rules-based sort of navigation. And then here's the car that I was driving. So yeah, this screen is really just the world. I can put whatever I want in here. And I can show you actually. Let me show you how I would put in a bunch of NPCs. So basically when you download CARLA, there is a folder for Python API, and in there they give you a bunch of example scripts, and you can see them here on the left, and there's one for spawn NPCs. Now, by default, spawn NPCs will spawn 10 vehicles and 38 walkers. And you can see it crashed at some point. But if I just run Python and then spawn NPC, and you give it a second, you see some errors about spawn collisions. Basically, it's just trying to find a good place to place that spawn. And then there they are. So now I have 10 vehicles and 31 walkers. So I don't know why the numbers are arbitrary, but that's what they are. So if I switch back over to the world screen, we can see we have much more activity. So we have this car that I guess was spawned by the NPC script. There's also pedestrians. There's a bike. That looks like a bike up there in that intersection. Yeah, so we have a bicyclist. And there should be several other vehicles around here. I guess if I go up higher, gain some altitude here, we'll be able to see some more activity. So there's our Wrangler down there in the bottom right. There's also a tunnel over here. There's another vehicle way over there in the distance. There's another bike that actually might be the same bike, but this can be pretty valuable to spawn these NPCs because well, now we have traffic, and now we have some, I guess, chaos in the world. And what I mean by chaos is, I mentioned that there's pedestrians. Yeah, here's a pedestrian right here. These guys, they'll just cross the street whenever the hell they want to. They won't care about crosswalks or anything. They'll just, step out in front of vehicles. So watch this guy. I bet he's gonna do it. Watch him not. Yeah, he's not gonna do it. But yeah, it's just extremely random walking paths. I mean, sometimes they'll follow the crosswalks, sometimes they just don't. And that can be pretty valuable to train against. This map, and there's several maps in CARLA. This is by far the most complex one. It has a roundabout, it has a cul-de-sac over there in the distance, it has this large looping highway. It has a rail line, and there's a road underneath that rail line. There's police roadblocks down there. Whoa, hey. Why is that pedestrian? So this is technically not part of the map. This is like the end of the map. And there's a pedestrian down there. Interesting. So you could, well, I don't know. I don't know if you could drive through this hole here if you wanted to or not. You know what? Let's try it. I want to try driving through and seeing if I can go over there where the pedestrian just was. So let me pull up my Impala. And I'm not going to follow traffic laws because I'm not training any models right now. I don't care about that sort of thing. Okay, that car looks like it just got pushed. Oh, no it didn't. I'm going the wrong way. That's what happened. So this client... I just wrecked into that car. So this client that I'm using to... Oh, is he pushing? There we go. Yeah, he was pushing. Anyway, this client that I'm using to control this car is Pygame. You can see it up there in the title bar of the window. I don't know too much about Pygame. I've never worked with it or anything, but it seems to work just fine. I haven't had any issues in playing it. See, these vehicles right here, I don't think they're... I think they're static. I don't think they have physics to them or anything. Yeah. Oh, but it does say collision with vehicle. So that's cool. Anyway, yeah, I've been learning a lot about CARLA, but it's all pretty much on the surface. Like, I haven't gotten into programming yet, and that's kind of what I wanted to do tonight. Is start looking into the API and seeing if I can attach myself to a sensor. So now I've got to figure out how to get back. Can I squeeze through? Yes, nice. There is one feature of this map that if I ever, and I know I'm going the wrong way right now, I said I'm not following the laws. If I ever do start training an AI model, there's... Okay, I'd never hit a pedestrian before, so that was the first time of me doing that. Alright, so there's one section of this map that if I ever do start training an AI model, I would be curious to see if it actually follows this. So you saw on that roundabout I just went through, like it's a four-way roundabout, so you can peel off at any point and go down one of those roads. This cul-de-sac down here kind of looks like a roundabout, but it's not. It's a cul-de-sac. It only has one entrance and one exit, and here it is. So it has this middle feature of this park, and if you look, as you come around, those are sidewalks, not a road. And then this is the road. So you can see it only has one entrance and exit. So if I go back around there, if you just glance, like, that kind of looks like a road. Like it has things that could be misconstrued as road markings. Did I just hit a... Okay, yeah, I just hit a thing, that's all. Now, if I use radar, I'll be able to see these pylons, but like in the real world, you know, I've seen this sort of setup before in the real world all the time, and very rarely are there these concrete sort of barriers, you know, unless you're in like a Walmart or something. That's another thing, is there's not very large, I guess, parking lots. Like the largest sort of parking lot I could see was, I think it's over here. Yeah, like this is the largest piece of like open space, and there's not even any parking spots, like markings. There's like shoulder parking, like right here, but I haven't really seen a good like trying to train a model to navigate like a Walmart parking or a Home Depot parking lot. So that'll be something that maybe this map won't help me with. Now, I mentioned that this does have, look, the Tesla Cybertruck. That's not what I was saying, though. This CARLA does have multiple maps. There's, I believe, 10 of them. I've only tried 2. And this one and another one. And the other one kept crashing anytime I spawned NPCs in it. Like, it'd work for a minute, they'd get in there, and then as soon as they would start navigating, they would crash. There was also a section, because I did get it to run a little bit longer, but there was a section of road where like no cars would ever pass. So they would just pile up there, and I think those would eventually start crashing out the program. So I haven't tried any of the other maps. That map specifically is kind of more of a rural sort of area. In fact, let me show you. So for me to be able to show you, I have to shut down my clients. So I'll shut down that Impala, and I'll shut down this Wrangler, which is still going strong. And those are all running these different, and there we go. My pedestrians just crashed. I didn't do that. They just crashed. But CARLA is still running. If I transition back over, you can see this is that same world that we were just in, but now there's no cars, there's no pedestrians. Everything is disconnected and been kicked except for that one car that I don't know what the deal is with this car. It was kind of like so that Jeep Wrangler I had doing the autopilot. This was going to be that for this stream, but it just crashed and it never disappeared, so it's just kind of stuck here now. But anyway, we don't care. I'm going to show you basically what the startup is for CARLA. So when you download CARLA, you get a zip package that comes with this, and this is all you get. So it's different on Linux, and it's a little bit more complicated on Linux, which is unfortunate because it works better on Linux. And all the documentation is really sort of Linux focused. But on Windows, you just double click here. Sometimes it works, sometimes it doesn't. I'll get these errors from time to time that say my video driver stopped working. And hang on, it's starting up on the other monitor. I'm just waiting for it to load so that I can switch it over. There we go. All right, let me go ahead and transition back over. All right, so you can see this is map 3. This is town 3. There is a way to change the town, and that's using the Python API. So in here there is in the Python API there is the agents, which you don't really have to worry about. You get CARLA agents, data, and dist. All this CARLA folder, that's just the sort of API in itself. You have examples and util. So examples are the majority of the scripts I'm going to be playing with tonight. But there's also this util, which has this config py in it. And there's some documentation out there about this. I haven't really looked into all of it, but I'm pretty sure that it has a help flag. So if I do Python, and then I need to go back one directory to util config.py, and then does it just help? Yeah, that looks helpful. Let's have a closer look here. Yeah, dash help, perfect. So we can set the map with M. Let's load a new map, and we can see all available maps. So if I just do -m -list, is that going to give me the list of maps? Let's try it. So -m -list. Expected one argument. Okay, so is it just -list? Okay, so those are all the maps that we have available. Apparently we can also set the weather. Wet noon and wet sunset. If Andrew was watching, I'd tell him that was a good band name. But he's missing out. So let's set it to a town I haven't tried before. This might not end well, but let's give it a shot. Town 1 and Town 2 is supposed to be pretty basic. They're just T-junctions, and I think Town 2 includes a roundabout. Town 7 is that, I guess, it's the one that kept crashing on me. Town 10, it sounds interesting because it says HD, and I would like to see if that means high def. like HD usually means. So let's go ahead and set that. So same one, we're going to do -M town 10 HD. So once I execute this, I'll transition over, and we should see CARLA reload. That script's still running. You can see it down here, loading map. I'll transition once that's done, actually. Oh wow. Okay, so it's just finished. Let me switch over. This is what we got. This is Town 10 HD. Oh wow. Huh. I wonder if I can do autonomous boating. That would be cool. So I've never seen this map before. Let's have a closer look. Several high rises. Looks like we do have parking lots. They're not marked though, which is unfortunate. Looks like there's cars on the side of the road already for us. They're probably not NPCs. They're probably just assets that are here. Oh cool, check out that graffiti. Is it considered graffiti when it's like part of the installation? Oh. This looks like... Well, if it weren't for those twisty buildings, I would say this kind of looks like Madison. I don't know, I haven't been to Madison in a while. Oh, there's like a cathedral looking thing. Or maybe that's a parking garage, I don't know. Fancy parking garage. Looks like we have a train station. Okay, so there's really just these two crossing roads and this loop of a highway. That's all I see in the way of roads. Although I do see these little like driveways, I guess. Let's go have a closer look at these driveways. Ooh, I wonder if I can drive in the parking garage. Okay, so this looks like the parking garage that you would see in like the plaza in Dallas. Oh man. So I wonder if I can get that thing open, because I'd like to drive a car into here. Let's try it out. Let's see if we can get a car to drive in there, because maybe it just doesn't clip. Maybe, yeah, let's transition back over. I'm going to show you how I get the manual control going. So basically it's just manual control.py. I just run that, and it gives you a list of commands that kind of tell you how to work this thing. So WSAD, S is only brake. To actually go into reverse, you have to use Q. There's a handbrake, there's toggle autopilot. So this is just the built-in stuff. I don't know if it's actually using like an artificial intelligence model, or if it's just hooking into the simulation and it knows where everything is, so it's just doing rules-based navigation. I imagine it's just that, but I don't know exactly. And there's some other controls here that are useful. Backspace is pretty useful because it allows you to just randomly switch over to another vehicle, which sometimes it spawns you as like a bicycle, which you don't want that, so you just press backspace and it gives you a new car. They have all sorts of like realistic cars too, like, you know, there's a Volkswagen, a Seat Leon, you have a Audi A2, there's another bike that's actually a motorcycle, yeah, Kawasaki Ninja. And I don't know if you can see it too well on the stream here, but up here it tells you the actual vehicle. So looks like we landed on a Tesla Cybertruck, which is cool. I've reserved a seat for the Tesla Cybertruck. It'll be pretty interesting to see if I actually get it, or how long it'll take, but that would be pretty cool. Alright, so I believe, you know what, before we go do that, I want to see if I can ramp these stairs. Oh, nope. Cannot ramp the stairs. Alright, so let's back out. Alright, so we're going to go to that parking garage and see if I can actually get into that garage. Maybe this big hunky vehicle isn't the best thing to try to take through this parking garage. We'll see. We'll see how it goes. Collision with static. Okay, so it's not going to let us through there. I wonder if there's another entrance on the other side. Oh, but there's an entrance to the parking garage. I wonder if we can get to that spiral thing through the parking garage. I'm gonna go ahead and change the vehicle. As much as I'd like to play. Perfect. Perfect. I was afraid we would have to use a motorcycle, but no, they have this dinky little thing in here. What's this called? BMW Isetta. Okay, so I wonder if the other side is open. We'll get to the API here in a minute. I kind of want to see if this map is worth playing with a little bit. This thing is actually kind of spunky. Alright, so that's that. So is there an entrance over here? No. Okay, so I don't think this parking garage is meant to get in. It's fine. So going back to the documentation, let's see here. So yeah, this was talking about basically world and client. Then we have actors and blueprints, maps and navigation, and then sensors and data. So the thing about sensors and data is I believe it's actually an actor too. So an actor is anything that plays a role in the simulation, and sensors is listed here. The spectator, I wonder if that's that view that I've been using to fly around the world. I don't know. But there's this blurb about blueprints. So basically all those vehicles that we're seeing, those are blueprints. So I can select any of those at any point, I suppose. But the script is just manual. I don't see a way to actually select a certain vehicle make and type. But they have Mustangs, like, you know, the old style Mustangs. Alright, so sensor data. A sensor is an actor attached to a parent vehicle. It follows the vehicle around, gathering information of the surroundings. The sensors available are defined by their blueprints in the blueprint library. That's all well and good, but I don't know how to use the library yet, so let's see here. CARLA offers a wide range of features that go beyond the scope of this introduction to the simulator. Here listed some of the remarkable ones. However, it is highly encouraged to read the whole first step sections before starting with the advanced steps. Is this the first step section? Yeah. Sure is. Okay. So I've read this whole thing. Kind of. OpenDrive standalone mode. Generates a road mesh using only an OpenDrive file. Allows to load any OpenDrive map into CARLA without the need of creating assets. Very good. Okay. That's good to know. I don't know where to get an OpenDrive file, but it's nice to know that I can grab one if I, or use it here if I got one. Sumo co-simulation. Run a synchronous simulation between CARLA and Sumo traffic simulator. Oh, interesting. So I can actually get like better traffic, I guess. This module is in charge of every vehicle set to autopilot mode. It simulates traffic in the city for simulation to look like a real urban environment. Okay, so autopilot mode is the same thing. Gotcha. It's not an AI, I guess is what I'm saying. Alright, cool. So I want to learn a little bit more about the API here. There is the Python API reference, but I think that's going to be a little too bland for a live stream. These are the advanced steps. Oh wait, it has... Oh, it has a detailed section for each of these first steps. Gotcha. Okay. World connection. Okay, let's read a little bit more about this. So, two things are needed. The IP address, identifying it, and 2 TCP ports to communicate with the server. An optional third parameter set the amount of working threads. By default, it is set to all. The CARLA client in the Python API reference contains a snippet that shows how to parse these arguments when running the script. So we can actually see that if we pull up that example. So going back to our example, we're going to use the manual control one just because I feel like I have a better understanding of what that thing's actually supposed to do. Manual control. Here we go. So yeah, it just prints this out to the console, and then I'm looking for where it starts CARLA. This is interesting. This is actually how it imports CARLA. So in that CARLA directory under dist, there's this. So it doesn't care about the CARLA version, but what it's doing right here is it's getting the major and minor version of Python, which here the distribution is only 3.7. And that was a problem for me because I had Python 3.8 installed, so I kept getting issues about like things not being imported properly and everything else. So I actually had to downgrade and specifically install Python 3.7 to get this to work, for it to pull up that distribution. I guess, you know, I could have just changed this string to point to 3.7. I have done swarm intelligence before, which would be cool. Oh, hey, Jake's here. Hi, Jake. They have autonomous bass boats? Yeah, I know about that, and it's super interesting. I think that would actually be easier than car, though. All the other cars have to chase all the other cars. Yeah, you know, having like a competition between AI racing cars. That would be kind of cool. Program police cars to chase you. Yeah. Sorry, I haven't been paying attention to chat too much. Anyway, yeah, so basically I installed Python 3.7 and this started working again because it immediately imports CARLA, and then that's where it would be failing at. So it's importing a few other things. I'm not entirely sure with what these stuff, like I think I know what this is, and probably this and this and that. I don't know what argparse, re, or workref are, but I'm not a Python programmer. I've done very little Python in my career, so this will be interesting. Looks like we're setting up some keyboard bindings. Oh wow, there's much more bindings than what's in the help file. Interesting. Minus and equals. I wonder what those do. Cannot import Pygame. Make sure Pygame package is installed. That was another thing, is I had to use pip to install Pygame and NumPy. So we have some global functions. We'll just skip over those. Here is world. Okay. Maybe world isn't being used yet. We'll skip world for now. We'll skip keyboard control, heads up display. That's that little thing off on the left that has all the sensor readouts. I don't know if you can see those very well in the stream. Fading text. Oh, this is the text down at the bottom that tells us events that happened, which you probably saw when I, you know, crashed into things. The help text, we've already seen that. Collision sensor. Okay. That'll be interesting. Line 700. Let's remember that because I want to see that later. Lane invasion sensor. What is that exactly? Yeah, we'll look into that here in a little while. This global navigation system. Okay. Inertial measurement unit. Radar. So this is something I'm really interested in my real world project, is getting some microwave radar sensor for my vehicle and actually starting to see things, because the thing is I can install these sensors on my vehicle and drive my vehicle like normal and gather data and telemetry, and that's really what I want to do. I don't know if I ever actually want to control my car in the real world. Maybe I'll feel differently about that once I know what the hell I'm doing, but really what I want to do, thank you, Jared. Really what I want to do is install the sensors on the vehicle, drive it around like normal, and just record and record. And then maybe, you know, using that open drive specification, create a map of the area where that telemetry data came from and replay it out in the simulation and see if I can get the car to do the same things I did in the real world when that stuff happened. I don't know. Baby steps, though. Baby steps. Let's see if we can actually pull in a sensor. But I want to see how this manual control is referencing the client. So we have the camera manager, which I would think would be a good place to do that, but it's... I don't know where CARLA's coming from. Skip this for now. Game loop. Okay, this looks promising. Here we go. CARLA, client, CARLA, host import. Okay, so I don't know what set timeout is. So let's try this. Let's do a little bit more reading, and then I'm going to actually try to instantiate the client and see what I get. So By default, CARLA uses host and port 2000 to connect, but these can be changed at will. The second port will always be N+1 2001. Okay, cool. So this just says args port. So it must be setting up default arguments somewhere. Okay. Arg parser. Oh, so okay, so that's what the arg parser library is. Yeah, okay, so port default 2000. So I haven't been setting that. That means I'm using the default port. Oh, there's a main. Gotcha. Okay. So the client is being defined in the game loop. Is this actually where it's being iterated? No, here's the iteration. Okay, so this is world.tick. Does my client have to advance the world tick? Okay, so this is getting more into like game programming, and if you've ever done a game loop in a program before, that's basically what this is right here. Well, it says it, but what you would typically have is you would have your engine, and that's taking care of things like physics and time. So you always think about like a 3D gaming engine, but really there's the fourth dimension of time. Like you can render a 3D scene, but if there's no time, you can't animate anything, you can't take any action. So the engine typically takes care of that. Why this client has a world.tick method, I don't know. So I'll want to understand more about what that is here soon. Let's head back to the documentation. So this says, once the client is created, set its timeout. This limits all networking operations so that these don't block the client forever, and the error will be returned if connection fails. So is this doing it? I imagine it is. Immediately. Okay, cool. It is possible to have many clients connected. It is common to have more than one script running at a time. We saw that when I had my Impala and the Jeep Wrangler going at the same time. Working in a multi-client scheme with advanced CARLA features, such as Traffic Manager, is bound to make communication more complex. Yeah, it makes sense. The client and server have different libcarla modules. If the versions differ, issues may arise. This can be checked by using get client version and get server version. You know what? Let's do that. Let's create a script where we create a CARLA client, connect to the server, and then print out the two versions. Now, both of these, the client and the server, were downloaded in the same package, so they're most likely going to match. But just as a test to verify what we've read so far, let's create the client and print out versions. So I'm going to, I guess, just put mine in examples. Why not? I'm not doing any source control or anything, so we'll call this oxys test.py. And since I'm not familiar with Python, let me just look at some. Okay, so if name equals main. Okay, I guess I don't know what that if statement does, but I'm just going to copy it anyway. And then I know Python has like special spacing. Yeah, okay. And then is there any way to end the method? Nope, I guess not. So we have to import CARLA too. I don't think we have to import NumPy or Pygame or anything because we're not doing that stuff. Let's see, glob, OS, and sys. So we'll need that to do the CARLA import. So let's color converter. Interesting. We'll just grab that for now. No reason to type all that out if it's already there for us. I don't know if we'll need these other imports. Let's have a look. Collections, date, time, logging. Yeah, let's use logging. And I don't know what those others are, so now back down to our main. which is way the hell down here. Okay, so I think we can just start doing things. Yeah, we're not using Pygame, so we'll do, how do you define a variable? You just type it? Cool. Carla.client, and then it said host and then port. I wonder if that's just an integer. It also said there was a third variable. What was the third variable? Amount of working threads. Okay, well, I'm not entirely sure. By default, it's set to all. Sure. Okay, we'll just keep that. And yeah, that's just an integer, so that'll work. And apparently, I can use hostname, so that'll be good. It says set timeout. Okay, so that's seconds. Yeah, 2 seconds is good. I don't care. So client.set. Looks like we have some IntelliSense going on here. I don't know how accurate these are. Set autopilot. Okay. Set timeout. We're just going to do 2.0 because that's what the one before it was doing. And then we wanted to... Oh, how did this do logging? I know you can just print, but maybe I want to do logging. Yeah. We'll do server version, and it said that that should just be what was it? Client dot server. I just saw some IntelliSense on that. Let's see if that was right. Get server version. Okay. You can get a lot of things. Get FPS, get location, get map. I wonder where this IntelliSense is coming from because I don't see a get server version. There is a place to go specifically for a reference, so I can do that later. Alright, this probably won't work, but let's try it. What do I call this? Oxys test.py. Let's just print, because I'm not entirely sure how logging works. What did I do? Why does that not work, I wonder? Oh, because it's print, not logging. Gotcha. Alright, so yeah, server version, client version works. I'm actually, let's do while, how do you do this in Python? True, I think it's true. There we go. I'm just going to do print client dot, what was it, get FPS? I mean, why not? Let's see what that does. That's a method. It's probably gonna crash. Yeah. Client has no attribute get FPS. Well, what does client have? Dot get FPS. Okay, so the IntelliSense isn't quite accurate. Let's go look at the reference and see what's available on the client. Okay, Carla actor. I want Carla client. Carla client methods. Their technical documentation leaves some room to be improved, huh? Alright, here we go. Getters. So get available maps, get client version, get server version, get traffic manager. Interesting. And get world. This rule will be later used for examples to load maps. Okay, so that's it. So the client doesn't really have a lot of getters and setters. Or I guess getters. It probably has more setters. No, it has even less. Set timeout. Okay, we've already know what that does. It's a float, seconds, new timeout value. Very good. Default is 5 seconds. So wait. It says I have to set it. If it has a default, why do I have to set it? You know what? Why not? Let's just not set it. See what happens. Let's get rid of this loop real quick, because apparently that doesn't work right. It doesn't care. It does not care. Let's go back to the documentation here. So once we have a client, I'm guessing there are some more things that we can do with it. But why we would need a client, I don't know. Okay, so we can load a specific world. Let's see here. Clients are one of the main elements of the CARLA architecture. They connect to the server, retrieve information, and command changes. That is done via scripts. The client identifies itself and connects to the world to then operate with the simulation. Besides that, clients are able to access advanced CARLA modules, features, and apply command batches. Only command batches will be covered in this section. They are useful for basic things such as spawning lots of actors. The rest of the features are more complex and they will be addressed in their respective pages. So what I want to be able to do is spawn a car. And a car is an actor. A sensor is also an actor. And the goal that I want to do tonight is spawn a sensor and put it on that car. Which sensor did I say I wanted to do? I guess it doesn't matter. I mean, a camera is a sensor. Well, is a camera a sensor? Let's see here. Core concepts. An actor. I mean, the spectator. Maybe that's what it means by the spectator, is the camera. Well, a camera is a sensor. And a sensor is an actor. Okay, so I need a car, a camera. I'm going to need a way to control the car, so I have to do all the keyboard bindings too. I wonder if that manual script has sensors in it. I bet it does. I mean, it has to, right? Change sensor position. Change sensor position, huh? Hang on. Let's run the manual control thing again. See what that is. I want to go. Oh, wow. Interesting. Let's change. I want to be Coca-Cola. Yeah. Alright, that's more like it. So I saw a view that was inside of the vehicle. Oh well. So N was changed. Whoa. What did it change me to? What if I drive around? Ooh, that's trippy. That might give me a headache if I do that for too long. So is that like a rangefinder, I wonder? Let's change sensor again. Okay, that's all black and white. I don't know if you can see that too well in the stream, but okay, that's even worse. That has nothing. That has absolutely nothing. Oh, this looks familiar. I think I've seen this in Tesla demos before. And then this is what it would be doing like AI on. What is this? I wish it would tell me what this is. Oh, now that's Lidar. That is 100% Lidar. Alright, this is motion. So when I stop, everything blinks out, but if I go, yeah. Oh, and that wide field camera. Yeah, wide field of view. And I think this is normal. Yeah. So if I hit 8, yeah, 9, yeah, and then 1, yeah. Camera is a sensor, yeah. What is this? What do you suppose this is? I wonder if this script tells us. Change to sensor 1 through 9. So what do they call K0, K9, KN, okay. Where is that keyboard binding thing? Keyboard controls. Key in, next sensor. World camera manager, next sensor. That's all it does. Set sensor. Event key. Okay, gotcha. Yeah, that's what I was thinking. Some sort of distance thing, and like each one of these sections that it's repeating is like the same. Like if this is 5 yards, then this is 5 yards, and this is 5 yards. But that doesn't make sense about what's going on in the sky over here. That's probably just a glitchy simulation sort of thing. Who knows? Let's switch back to regular camera. Here we go. Alright, so I want to see what it means about sensors. Let's get into control vehicle physics. Okay, so they actually have tutorials. Create a sensor, look at that. I mean, why not go through the tutorial? Let me just look at what the API reference has to say about sensors real quick. CARLA.sensor. Collision detector. GNSS, IMU. Okay, so there was one that was all black. I wonder if that's the collision detector. Let me... Alright, so let's just ram into... nothing. Camera depth raw. Yeah, okay, so that's camera depth. Grayscale. Logarithmic grayscale. Okay, so now it's saying stuff down at the bottom. Yeah, Lidar raycast, dynamic vision sensor, distorted. Okay, I didn't notice it was saying this stuff down at the bottom before. Maybe somebody can go back in the stream and tell me if it was doing that and I'm just being dumb. So it doesn't have all these sensors. Well, so maybe it does have the collision detector, but like, you know, maybe that's just what this graph is over here on the left. Because whenever I hit something, let me just take the front end off this Audi. Bam, right there. See, in collision with building. So maybe this is just all sensor output. Let's see here. Traffic light, that's cool. So I can like, I wonder if I can control the traffic lights. That would be setter. Yep, set green time, set red time, set state. That's what I would want to do. Set yellow time. Okay. Cool. So let's go back to that tutorial. How to add a new sensor. Wouldn't I want to know how to add a vehicle? Assets, tutorials, general. Yeah, okay. So add friction triggers. Box triggers that can be added on runtime and let users define a different friction of the vehicle's wheels being inside those types of triggers. For example, this could be useful for making slippery surfaces in certain regions of maps dynamically. That's cool. So like you can simulate a semi-trailer that has tipped over that was full of like anal lube or something and simulate what it'd be like to drive. Yeah. Maybe I'm gonna switch my goal here. Control vehicle physics. Nice. Contribute access. Create. Let's see what adding a vehicle is like. Add a four-wheeled vehicle or add a two-wheeled vehicle. It's different. Find the skeleton, import, and prepare the vehicle. Okay. The very moment the model is finished, to a simple test in CARLA. Oh, okay, so is this more like creating the blueprint? Because if this is just creating the blueprint, I just want to know how to import the blueprint. Because yeah. Is this using Blender? Maya Blender or whichever software used for modeling. Okay. I looked into this sort of stuff before, doing 3D modeling and animation stuff. It was pretty cool. Really time consuming. I thought you'd be able to do things a lot faster. No, I mean weeks and weeks just to like do the simplest of things, or things that you would imagine are entirely simple. Oh, hey, look, you can set the specific vehicle. Very good. So this isn't going to tell me how to import it. I'm going to have to go look at that script on how to do that. Okay. So this create a sensor tutorial is probably about like creating a new type of sensor. Yeah. This story explains the basics of adding a new sensor to CARLA. It provides the necessary steps to implement a new sensor in, yeah. So this is talking about at like an engine level, how to add an entirely new type of sensor. Like say you wanted to add a thermometer for some reason. This is what this tutorial is for. So it's not about, yeah. That's fine. That'll be useful in the future. Today, not so much. So maybe this will tell me how to do it. Yeah. Okay. So I should listen to the documentation when it says read the first four core concepts first. Yeah. So this tells me exactly how to do that. So let's go back here and get through it. So we did that. We did that. World connection. A client can connect and retrieve the current world fairly easily. World.getWorld. The client can also get a list of available maps to change the current one. This will destroy the current world and create a new one. Yeah, that's what I showed you with that configure script. Every world has an ID or episode. Every time the client calls for load world or reload world, the previous one is destroyed. A new one is created from scratch. with a new episode. Okay, so an episode is like a simulation run, or like an instance, I suppose. A unique instance. The engine is not rebooted in the process. Okay. I hope they're good at their garbage collection. Okay. Commands are adaptations of some of the most common CARLA methods that can be applied in batches. For instance, the command set autopilot is equivalent to vehicle.set autopilot. Enables autopilot for vehicle. However, using the method Gotcha. Okay, so that would make sense if I'm doing things at scale. So one thing that I want to do is I want to basically have my main desktop running the simulation. And I mean, this is a pretty beefy desktop. I mean, it has 128 gigs of RAM, has a Ryzen 9 at 3.8, and the video card, I mean, it's not the best, but it is a 1070 Ti, which is good enough for just getting started. So I want this computer to just run the engine and the simulation, and then I want like a stack of Raspberry Pis to run the clients, or like maybe something a little bit beefier than a Raspberry Pi, because I want to do neural networking. I want to do artificial intelligence to actually control the simulation. So okay. Sorry, I'm just thinking about... that's not for tonight anyway. This becomes extremely useful for methods that are usually applied to even hundreds of elements. Yeah, so if I wanted to like set all traffic lights to red. Oh, that's a thing I could do, is I could simulate, you know how like when a traffic light fails it goes into that flashing red stop mode, I guess? I don't know what that's called. I guess you could simulate that using a client. The following example uses a bash to destroy a list of vehicles all at once. Cool. All the commands available are listed in the latest section of the Python. Okay. Other client utilities. Okay, cool. So the major ruler of the simulation. SE should be retrieved by the client. It does not contain the model of the world itself. It is part of the map class. Instead, most of the information and general settings can be accessed from this class. Okay. Oh, okay. So the actual like mesh that is the world is the map class. The information that makes up the current simulation, I guess, is the world. So actors in the simulation and the spectator. I'm pretty sure the spectator is that window that I use to fly around. Blueprint library. Oh, okay. So if I add things to the blueprint library, I have to add it to the world. Gotcha. Alright, so some of the most important methods are getters, precisely to retrieve information or instances of the elements. So what if I wanted to write a program that actually controlled the vehicle? And I know I'm very far from actually wanting to do that in the real world. Like, I don't even know if I wanted to do that. I would do your neural network on an FPGA, but I'm still having trouble even making the freaking UART on this one. That's nice. I'm glad you're playing with that FPGA. I can't wait until you get some wins on it to share, because you always do something interesting when you do stuff like this. Okay, so I can look at CARLA.world. Is that going to take me to the Python reference? Yep, sure does. Actors. The world has different methods related to actors that allow for different functionalities. Spawn actors, but not destroy them? Hang on. Where did I say something about destroying actors? Carla command destroy actor. Okay. So would that not be actor.destroy? But not destroy them. Weird. But isn't a vehicle an actor? Yeah, a vehicle is an actor. And this says I could call vehicle.destroy or whatever. Where was it? Oh no. Okay, so maybe this is the only way to destroy actors. I don't know. Get every actor on scene or find one in particular. Access the blueprint library. Access spectator actor. Simulation's point of view. Okay, so yeah, that the spectator actor is the simulation's point of view. Very good. Glad that's cleared up. Retrieve a random location that is fitting to spawn an actor. Okay. Spawning will be explained in second, actors and blueprints. It requires some understanding on the blueprint library, attributes, etc. That's to be expected. Okay. Weather. So the weather is not a class on its own, but a set of parameters accessible from the world. The parameterization includes sun orientation, cloudiness, wind, fog, and much more. Interesting. The helper class is used to define a custom weather. Interesting. So, wind. So I can set it to be super windy. Because in Amarillo, like the wind can get so bad that it'll blow semi-trailers off the road. I wonder if those physics exist in the simulation. Oh well. We're not worried about weather right now. We'll deal with that stuff later. Oh yeah, dynamic weather. I did play around with that a little bit. Basically, it just changes the weather every so often. Night mode starts when sun altitude angle is less than 0, which is considered sunset. This is when lights become especially relevant. Street lights automatically turn on when the simulation enters night mode. The lights are placed by the developers of the map and accessible as CARLA.light objects. Very good. Properties such as color and intensity can be changed at will. The variable light.state or light_state type of CARLA.light state allows setting all of these in one call. Cool. Street lights are categorized using their attribute light group. Okay. I have an idea. Make it change the weather based on where your car is. So like if I'm on the west side of town, spawn a tornado on the right side of town. I don't think you can do localized weather. I think it's weather that applies to the whole thing. But I get what you're saying, like make the clouds move and the sun go up and down. So that's not a bad exercise. Like it sounds funny and everything, but that would prove that yeah, what I'm doing is accurate because there is a GPS sensor. So I can get a car, spawn a GPS sensor, split the map up in the coordinates, and then based on the coordinate I'm in, change the weather. Yeah. How long are we into this? Man, it's already been an hour. Okay. We'll see. We'll see how far we get, but I like that idea. Thank you. Let's see, vehicle lights. User, each vehicle has a set of lights listed. Light state. Oh wow. So some cars don't have lights. Good to know. The lights of a vehicle can be retrieved and updated anytime using methods. Customize the light setting. Lights can also be set in real time using the environment. Okay. Debugging. Okay, that's cool. World snapshots. World settings. Oh, we've been an hour. Yeah, I guess I don't have too much going on. These determine rendering conditions, simulation time steps. Okay, so the simulation does take care of time. Good. Variable time steps. So I can speed up or slow down the simulation. Additionally, you put a light sensor. So I don't think there is like a photoresistor sensor or anything built into CARLA. So like I would have to build that. But like that's the thing is, you know, now that I know how to create a sensor, I could create a photoresistor sensor to detect day-night cycle. I could put tire pressure sensors, and I could simulate a flat and like what the simulation would do I can go pretty far with this, but that's all for another night. We need to get down to the basics. Alright, so that's it for the world. Actors and blueprints. So this is where we should be able to spawn a car. Actors are not only include vehicles and walkers, but also sensors, traffic lights, traffic signs, and the spectator. It is crucial to have fully understanding on how to operate them. It is crucial to have fully understanding on how to operate them. Okay. Use a camera. Yeah, I could use the camera. Detect light level using the camera. But then, we'll talk about it here in a little while. This section will cover spawning, destruction types, and how to manage them. However, the possibilities are almost endless. Experiment, take a look at the tutorials and the documentation, and share doubts and ideas with the CARLA forum. I don't know if the author of this is a native English speaker. I'm gonna help him out a little bit. Need to authenticate my GitHub, not Google. I just set up dual auth on GitHub like the other day, so this is new to me. Wonder if I'm supposed to be doing this on stream. Maybe there's a security risk in doing that. Yeah, that's fine. It is crucial to have full understanding on how to operate them. The section will cover spawning and how to manage them. However, the possibilities are almost endless. Experiment. Take a look at tutorials in this documentation. Share doubts and ideas in the CARLA forum. Doubts and ideas. I mean, grammatically it's not wrong, but like, I don't know. But that is definitely wrong, so we'll just, why not? Give back to the community. There. Somebody probably told me, well, I'm stupid for doing that, but yeah, it is what it is. They can take it or leave it. Where are we at? Here we go. Alright. So we have blueprints, actor life cycle, types of actors. Okay. Blueprints. These layouts allow the user to smoothly incorporate new actors into the simulation. They are already made models with animations and a series of attributes. Some of these are modifiable, and others are not. These attributes include, among others, vehicle color, amount of channels in the Lidar. Oh, wait. So, do the blueprints include the sensor suite? I didn't expect that. Available blueprints are listed in the blueprint library along with their attributes. Okay, let's go have a look. I want a car. Blueprint library. How would I get a car? Vehicle, okay. So I can select a specific vehicle. We have that Chevrolet Impala. We have a Charger, BMW, Okay. Number of wheels, object type, role name, sticky control. I wonder what that means. Sticky control. Oh, hey, this has more. Hang on. Color, driver ID. Number of wheels, object type, role name, sticky control. Number of wheels. What does that mean? Like, if I had an... okay, so some of them are modifiable, some of them are not. Gotcha, gotcha. So driver ID. Gotcha, okay. Oh, you know what? Because this is a bike, so I'd have to also spawn like an NPC, like a walker or something, and then I'd have to attach that walker to the bike. I imagine that's what that's about. Although I'm assuming, I'm speculating, so I'm not entirely sure. You know what? Can I click on it? Nope. Okay, back to where we were. The CARLA Blueprint Library class contains a list of CARLA Actor Blueprint elements. It is the world object who can provide access to it. Blueprints have an ID to identify them as the actors spawned in it. The library can be read to find a certain ID. Choose a blueprint at random or filter results using a wildcard pattern. Oh, so I can get... Nice. Let me look at those blueprints again. I wouldn't want to get like any vehicle at random because I don't like bikes. I don't like motorcycles. Like, I don't see how that's useful to put autopilot on a bicycle. Like, I have to pedal anyway. Maybe an electric bike. Like, there's maybe an argument there, but it's not my goal, so I want to filter those out. Besides that, each CARLA actor blueprint has a series of that can get and set. Okay. Actor life cycle. So the world object is responsible for spawning actors and keeping track of these. Spawning only requires a blueprint. And the CARLA.transform stating a location and rotation for the actor. Okay, so that's pretty typical of any sort of gaming engine. Is you have to give it basically the Cartesian, not only the Cartesian position locations, but also like rotational and angular coordinates as well. The world has two different methods: spawn actor, try spawn actor. Returns none if spawning fails, raises an exception if spawning fails. Okay. Dang. So I would have to. So is there not a way to like find a spawning point? Because I really don't want to have to deal with that. Remember that rotation. Yeah. So this is using the Unreal Engine. So defined as pitch yaw roll that defers to pitch yaw roll. Gotcha. Wait. Pitch yaw roll. Roll pitch yaw. Uh-huh. But you can set it. Okay, it's fine. The actor will not be spawned in case of collision at the specified location, no matter if this happens with a static object or another actor. Okay, so this is interesting. So far we've been looking at the Python API. And I've read a couple of times in a few different places that there's a C++ API. Neither of those languages are my daily driver. C# is my daily driver. So I'm wondering if there is a C# client API for CARLA. Demo project for developing the new build system and architecture of CARLA. This new architecture supports multi-client, multi-agent communication. Basically, any number of Python clients can connect and send instructions to a simulator simultaneously. The result is a new API that allows finer control of each. Okay, so he's creating an entirely new API. Hey, look, he did the same thing we did. Cool. Well, this is basically what I was going to write. I could just copy and paste it. But I want to read the documentation. What is this GitHub repo? What did they change? See, I would like to communicate via RPC directly to the server using C#. That's what I would like to do. But there doesn't appear to be a library out there currently that is able to do that. So that's unfortunate. Maybe in the vast amount of spare time that I have on my hands, I could do that. But yeah, I guess we'll stick with this for now. Okay, so we have get spawn points for vehicles. That's good. Get random location for walkers. Okay. Okay. So that's how I can get a spawn point. Very good. Get random location from navigation. Get spawn points. I just want to get like a random, like one singular. Okay, so let's look at that again. There was like a try spawn, right? So we're going to want to call that first. Or maybe we want to pick our blueprint first. I don't know. Let's pick our blueprint first. Blueprints have an ID to identify them and actor spawned in it. Okay, so let's just start with our vehicle and see if we can get a vehicle spawned. Here we are. Oxy's test. So I'm going to have to import random. There we go. Blueprint library. So where did blueprint library come from? We're going to have to find out. Blueprint library. World.get blueprint library, but where did world come from? World comes from client, which should be world equals client.get world. I think I recall that's what it was. Let's go double check because I don't want to throw any errors. There's a Python reference. Client getters get world. Yeah. Okay. I was right. Cool. So now we have the blueprint library. We've selected a vehicle. We'll come back to sensors in a minute. We need a vehicle first. I don't care if it's a bike. Huh? What is this? Attributes have a CARLA actor attribute type. It states its type. So modifiable attributes. Wait, do I have to do that? I'm going to omit this for now, but if I get errors about like attributes not being set, I'll have to remember to come do this. Oh, I see chat has additionally put a license around the car. Okay, we read that. C# has a similar syntax to C++. Shouldn't be that hard to learn C++ as long as you can get the linking to work right. Not necessarily. The delimiter between classes and properties and methods and everything is quite different. Also, once you get into more complex stuff like lambdas and enumerables, and collections and even core concepts like garbage collection, that's when you start running into vast differences. Syntax isn't everything when it comes to effectively using a language. That's the part that I have the most trouble with. Don't know what part you were talking about. Or wrote a paper for C#. Or wrote a wrapper for C#. I could write a wrapper for C#, but it's almost the same amount of work to just go ahead and write my own RPC client. I wonder if I could use gRPC. That would be kind of cool. Anyway, I don't have time for either one right now, unfortunately. I wish I did. Actor lifecycle. Alright, so this is where we were talking about spawn actor. So it's world.spawnActor is what we'll be using, but we have to do a transform first, and it was saying, I get spawn points. Where was that try spawn? I saw the try spawn. Yeah, returns none if the spawning fails. Okay. What does it return if it's good? Try spawn. CARLA.actor. Okay. Map.get spawn points for vehicles and for walkers. An actor can be attached to another one when spawned. Actors follow the parent they are attached to. This is specifically useful for sensors. The attachment can be rigged, proper to retrieve precise data, or with an eased movement according to its parent. I wonder if I should model an RX-8 for CARLA. I think that would be cool. The next example attaches a camera rigidly to the vehicle. So okay, so that's where we'll get to sensors here in a minute. Let me. Alright, we did that. So now we have our blueprint. I'm gonna do. I want to make sure we don't get a bike. Let's just do a Tesla. Why not? I might end up with a Cybertruck, but it's whatever. So now that we have our blueprint, now we need to get those random spawn points. I think that was a world dot something, but yeah. So we're gonna do world dot get spawn points, and now we just need to like grab one of those. So nope. Does Python have a do while loop? Python do while. I guess Python does not have a do while loop. Bummer. So I guess spawned equals false, so file. While not spawned. Yeah. Wait, does that not work in Python? How do you invert a condition in Python? Are you kidding me? I don't know. Maybe that was the problem. I don't know. We'll do this for now. Well, not spawned. we want to try to spawn. So lock equals 0, and then we'll do let's see, where was I? Basically what I'm trying to do with this spawn and lock is I want to iterate over these points. So spawn points and then lock plus plus. Oh shoot, does that not work in Python? We'll see if that works. Who knows? Who knows? I'm not a Python guru. If anybody has suggestions, I'm open to hear it. So now that I'm able to iterate over the spawns, I need to be able to try the spawn in this loop. And I don't know how to define a variable without instantiating it in Python either, so that's going to be a challenge. Well, we know we're going to need our spawn point, which is going to be a CARLA.transform, and then we can do spawn point.location will be equal to, I guess that would be this. Yeah. And then with that, we could actually try spawning our actor. So that would be actor equals world.spawn actor. Yeah, and we're going to do our vehicle blueprint and our spawn point. Now, if actor does not equal none, okay, yep, that's a thing. Then we're gonna set, actually no, let's set spawned so if actor is none, that'll be true. We want spawn to be true only when we do get an actor. Now that's the thing, is like, how do I define, let's see here, Python, declare variable without value, I guess. Possible, I'm going to declare about var value. Var equals none. Why not just do, yeah, okay. Yep, perfect. So actually we can clean this up a little bit now. So actor equals none. There we go. I'll get rid of this. Our condition will be actor does not equal none. So while actor is equal to none, we will do this. There we go. Now another thing that I'd like to do is if I could do lock plus plus, but it doesn't look that I can do that. So Python inline increment. Okay. Python is not C or C++. Yeah, I know. These people are so toxic. Is not an operator. It is two plus operators. A plus operator is the identity operator, which does nothing. Clarification. Unary operators. Okay. Okay, but that's a different statement. So, yep, looks like we'll just have to do it this way. And that is okay. For now, I suppose. Good, so then we'll have our actor. If this actually spawns an actor, then we'll print the version number. That's what will happen. So what's running here? Oh, do I have a client running? Oh yeah, our little experiment with sensors. Yee. Cool. I'll use this guy to try to find our Tesla. Let's switch over to here. Let's try running our script. Alright, we got an error right out the gate. Very cool. Line 55. Main. Oxy's test. Line 46. Spawn point. So spawn points. That should be a list, right? So Python get nth element of list. Actually, hang on. Python for each loop. Do I want to do this? I don't know. For item in list. Func item. Okay. PHP, C#, Python. Okay. So let's do that. Let's for spawn point in spawn points, we will basically do this. I see, okay. Block. Do block there. And then this will just become block. And get rid of that. If actor does not equal none, continue? Is that a thing? Looks like it. I wonder if I need this in Python. Probably. We'll just do it like that. Let's see what that does. Actually, let's do print trying spawn. Print spawn. Okay. See what this does. Alright. Expected an indented block. Ah, right. Whoops. Okay, cool. So that means it spawned actually, but the client disconnected, so number of vehicles is still 1. Let's try running this one more time. Oh, do I have to keep the client connected for that to work? Okay, I got an error. Okay, so it doesn't like this. Let me look at the documentation again. So I was using this world.getRandomLocation from navigation. Spawn point.location. Spawn point.location. I wonder if I still need a rotation. So this blew up on line 45, which is here. How do I get the type of an object in Python? Are they even called objects in Python? Like, I don't know. Can I just, yep, I can just print. Cool. Class string. What? Oh, yeah, that is a string. There we go. It's a transform. And that's expecting a transform. Let's do this then. Let's do lock, and then what was that? Rotation yaw equals 180. Yeah, why not? That'll work. Let's see. Nope. Rotation is not defined. Okay, let's go back to that documentation. Not that documentation. This documentation. CARLA.rotation. Okay. All right. So we have, oh, it wants transform rotation. So what is that? Let's go look at the API. Let's just go look at the actual reference API. CARLA.transform. CARLA.rotation. CARLA.transform. It takes two. CARLA.location. Oh, what is this? Self, location, rotation. Okay. Give forward vector, okay. I'm so confused. Like, why couldn't I just put in lock? Like, why wouldn't that work? Does it work? Interesting. Wow. Oh, shit. My for loop condition is inversed. And now I am in a sea of Teslas. But hey, we spawned a vehicle. Oh, they have physics. Where's it going? Okay. Cool. Oh my god, look at all these Teslas. Oh. It's just dominoes. Wait. Isn't that like a thing with Teslas? Is like if you're about to wreck into them, they'll... wonder if that's what we're seeing. Anyway, so that's cool. Jeez. So many did it spawn? 156. Cool. Yeah, so when trying to spawn, yeah, okay, that worked. I don't know how to despawn them. I could restart the simulation. Actually, yeah, I do know how to despawn them. The documentation told us that earlier. Coming back here, second actors, it told us that we can... I think that was here. No, it wasn't. It was on directors. You know what? I'm probably just going to restart the simulation. Might as well start out with a clean slate. So let me pull this guy over. Look at all these Teslas everywhere. Elon Musk has been busy. Well, that's a spawn point? Interesting. Oh, I like this area. This actually looks like downtown Fort Worth right here. Anyway, closing that down. Let's make sure those clients shut down. Shut that down. That's shut down, and this will close eventually, I suppose. There we go. Alright. And now we'll just restart the simulation. Oh yeah, we're on this map again. Oh well. We'll just play around on this map. I don't feel like changing it right now. Let's get our manual control back up. Here we go. BMW, huh? Very cool. Run the hell out of that red line. Yes, that's my blue car up there on that simulation. Very nice. Alright, so we're just gonna park him on the side of the street right here. Alright, there we go. Alright, so our for loop was... Maybe, oh, this needs to be brake. Oh, okay, that makes total sense. Let's go over here, and let's go ahead and run Opti's test again. And now it looks like it spawned, so let's go try to find it. And it'll probably be faster if I use this screen. So there's going to be a Model 3 around here somewhere. Oh, is that it? That does appear to be our Model 3. Very cool. Now, I don't know how to despawn it. That's still a problem. But at least we don't have 156 of them, so we can just spawn another one once we figure out how the sensor works. So, let's now try to spawn a Model 3 with a sensor. And actually, while I'm doing that, let me try something here. We'll turn on autopilot for this guy. And I'll let that run for a second while I do something over here. we go. I like that setup. We'll use this for a little bit. All right, cool. So now that actually here, let me try something real quick. I want to move that over a little bit more. Yeah, there we go. Much better. Okay, so now that we've able to successfully spawn, maybe, you know, it'd be appropriate for me to try to... Self-driving AI needs to be done in layers. Yes, yes it does. What layers do you propose? Because right now I'm not even at the AI part. I'm just at learning the tool suite and the sensors and how to interface with them. World building layer, whose inputs are all your sensors. Yeah. So that's the thing, is like there's this open drive specification that is supposed to allow you to be able to simulate all this. So like if I'm able to put a suite of sensors on a car in CARLA and have it rebuild the open drive specification of the map that CARLA is running, then what I could do in the real world is use that same suite of sensors on my RX-8 and drive it around the real world and have it create an open drive format file of the real world. And then I could load that into CARLA and do some additional testing. So I don't know. Navigation, control output. Yeah, yes, there's several different paths to that. So my control output is definitely the last stage. I'm not confident in actually controlling a 3,000-pound piece of machinery with bits yet. I don't even know if I'll ever get to that stage, but it's a nice exercise. Anyway, Jarrett, I appreciate you joining me. I'll probably be doing more of this. It is, shoot, we're almost 2 hours in, so I'll probably be wrapping up here in a minute, but I still want to get this sensor added. But thank you, Jarrett. Have a good night. I'll talk to you soon. Take care. Okay, so let's grab, whoops, didn't mean to do that. Let's grab that documentation I was reading. So where did it get the camera BP? I guess that would be... Let's go look at a specific... sensor. I don't know what .dvs means. Back clip, blade count, bloom intensity. RGB, okay. Lidar. GNSS. So this is the sensor we were talking about earlier. Let's do that. Yeah, let's do that. Okay, so now that we have our actor, now I want to add our actor. So camera world dot spawn actor. We'll call this GNSS relative transform. Okay. Attached to my vehicle. Actually, yeah, let's call that there we go. Okay. You probably can't even see that, but basically I choose that to actor. So that ought to spawn a sensor. Let me just continue reading this documentation a little bit first. Once spawned, the world object adds the actor to the list. It can easily be searched or iterated on. So actor.getActors, find ID. So I guess what I would want to do is, I don't have this relative transform, so let me add this relative transform. That's CARLA.transform. Shoot, you know what? No, we're just gonna make it the exact same as the vehicle. Oh no, actually it's relative transform, so relative, shoot, there we go. We're going to do CARLA.transform, and we're just, see, I don't know if this is valid. It probably isn't. I'm going to run this and see. Vehicle.destroy. Is destroy right? Actor.destroy. Lowercase. True if successful. Okay, cool. So let's run this and see what happens. Positional argument follows keyword argument. Okay, so we have world.spawnActor. Let's go have a look at that reference. CARLA.world.spawnActor. What is dunder methods? Okay. Try spawn actor. Attachment equals. Okay. There we go. Let's try. Collision at spawn position. So now I need to figure out how to do that relative transformation. CARLA.transform. Okay, so apparently I can just do Carla dot location and Carla dot rotation. So that'll be 0 across the board, and then I can just do relative. Yeah, let's see if that works. Okay, fine. Let's do 111. Maybe that'll set things off a little bit. Spawn failed because of collision at spawn point. What? Oh wait, shouldn't it be try spawn? Yeah. Okay, so we have another Tesla over there. Line 52. Let's try this again. So it doesn't like this because it worked fine before that. Okay, apparently it didn't. I've changed something else. Python argument types in world. It takes actor blueprint, yes, and transform, yes. Carla.transform, yes. Location and rotation. We have world. Yes, that is world. Try spawn actor. Yes. Attached to vehicle. Yeah. Okay, so what if I just do lock? What does that do? Whoops. I'm getting more Teslas. So there's Teslas all over the place now. It's fine. It's fine. Maybe I need to figure out what my type is. Hang on. So Actor blueprint, yeah. And this takes an actor blueprint, yeah. World, actor, transform. World, actor, transform. Actor, actor. Okay. And attachment type. Attachment type, rigid. Okay, but that's already... That's already there, so let's actually try just removing that. Oh, I think it... Let's try that one more time. Yeah, well, okay, and it removed it. Very good. So now actually what I want to do is go through and remove all the Tesla actors. So there was a method here for world.getActors, but I want to know if there's a way to like filter that. So getters, get actor by actor ID, get actors, actors ID. Can I filter that? I can. Alright, cool. So world dot get actors, get actors, that gives me an actors list. Dot filter, and then I can filter on vehicle.tesla. So now for Tesla in here, we're going to tesla.destroy. So this should kill all of the Teslas. And if you look down here where it has the vehicle number, we should see that drop back down to 1. And then it'll click back up to 2 and drop back down to 1. So let's see if that works. Let me try something here. Wildcard pattern. Vehicle type ID. That's the blueprint used. Okay. Okay, that gives vehicle, but we have vehicle.destroy. CARLA.vehicle. What does that give us? Isn't there a way to like destroy all actors? Like I'm pretty sure I saw something to that effect when we were looking at this. Actor life cycle. Oh, something just crashed. I wasn't paying attention. Trying to operate on a destroyed actor. The actor's function was called the actor is already destroyed. Okay. So our BMW got destroyed somehow. No matter, I will start up a new one. There we go, and set it to autopilot. And we're off. Okay, that was weird. I don't know what happened there. Anyway, back to the documentation. I saw they gave us like a little blurb on like how to destroy a bunch of actors all at once. And maybe I don't want to restart the simulation. Yeah, here it is. Okay. So we get to try batch now. So vehicles list. X. Okay. So that was basically this. So this will be vehicles list. There we go. That should destroy all of those vehicles. Let's see. And we're down to one vehicle. Very good. So I'm just going to comment that out for now because we're not going to keep that around. So now what I want to do is I want to kind of hold on to it. While true. Continue. Yeah. We'll just do that to where it holds our thing. So if I run this, wait, hang on. So basically I'm going to create the vehicle, spin up a infinite loop, which will basically hold the vehicle active, and then once I exit the loop, it'll destroy the vehicle. I think that's how that'll work. I don't know. Let me just Google something real quick. Python run command before exit program. Ooh, there we go. So it's basically saying try while. Yeah, okay. Can't hurt. Let's see if that does the thing. Okay, spawned. I see two. You can see it right here. Now if I exit this, we're back down to one. But we got an exception. What's the deal here? Keyboard interrupt. We expected that. Yeah, that's not an exception, it's just a traceback. Ha. Oh, and it finally spawned a Cybertruck. Cool. Let's drive over to it. Autopilot off, and we're off. I don't know exactly where it is, so we gotta find it. It's most likely going to be at the first spawn location that other Tesla was at, because, yep, there it is. So that's our Tesla Cybertruck that it has spawned. And now if I control C out of this, it goes away. Let's do it again. Yeah. Very cool. And it has a sensor. I don't know how to check the sensor. Actually, maybe that's what we can put in our infinite loop thing. Yeah, so we can set autopilot on it. So let me move this car out of the way. There we go. So we can actually, here, let me set that one to autopilot, why not? So now, we can do vehicle.set autopilot. I don't know if that requires a boolean. Let's just go check the docs. Python API, CARLA.vehicle, where are we at? Vehicle. Vehicle control. Nice. That's what we're going to use when we start doing AI. But anyway, vehicle. It's under set autopilot. Enabled equals true. Okay. As default to true. Okay. Fine. So if we just call set autopilot, that's enough to get it rolling. And now I want to read from the GNSS. So if GNSS does not equal none, we're going to print some stuff out. Print GNSS dot, I don't know. What attributes does this thing have anyway? Sensors and data. Settings, spawning, listening. Sensor.listen. Okay. Every sensor has a listen method. This is called every time the sensor retrieves data. It's a lambda. Okay, cool. So this is what we want to do. Frame number when the measurement took place, time spent when the measurement took place, is listening, sensor tick. Okay, cool. So we're going to have to create a callback. So def GNSS listener. And we're just going to print, actually, what does that take? Okay. Event. I don't know what an event has though. Let's go to the Python API, look at CARLA.event. Hopefully. Nope. Okay, so there's probably a GNSS measurement. Alright, so let me pull this back over. Class that defines the GNSS data registered by the sensor other GNSS. It essentially reports its position with the position of the sensor and a open drive georeference. Altitude, latitude, longitude. Cool. Inherited from sensor data. But that's not the event. Maybe it's called sensor event. Sensor data. Okay. Collision event. Base class for all objects containing data generated by a CARLA.sensor. This object should be the argument of the function said sensor is listening to. Okay, in order to work with them, each of these sensors need for a specific type of sensor data. Okay, so that's what I'm getting is this. Cool. So we're just gonna print altitude. Latitude and longitude. We're going to do event dot altitude, event dot latitude, event dot longitude. Yeah. Alright, so that's all I want to do for the callback right now. I don't want to do anything else yet. But that'll be where we set that weather for the coordinates, or the quadrants that we enter. So back to here, data. Wait. Sensor.listen. Okay, so down here, GNSS.listen, just like that. Maybe I want to do lambda data do something. Okay, no, that's going to be this, the data. Gotcha. Okay, gotcha. Okay, so this should work. That means I don't necessarily need this. So this should spawn the vehicle. Let me take control back over. Oh, and that crashed. Look at it. It's still going. I don't know if you can see it. Yeah, it was behind my webcam. My bad. Hang on. Let me just... Look at it. See it over there? It crashed. Okay. Well, let's head over here to our Tesla. So I'm going to place it right there and fade back over. Alright, so you should be able to see the Tesla. So it's going to, basically it's going to disappear now. I'm going to call this again. It's going to spawn the Tesla in, create the GPS sensor basically, and then it's going to start the listener. Then I'm going to turn on autopilot, and it should start driving autonomously. Well, through autopilot, not through AI or anything. And as it moves, we should see the GPS output into the console here. So let's... Oh, wow. Whoa, whoa, whoa. Okay, spawn the vehicle. Not enough arguments for form. Oh, I didn't. Gotcha. 1, 2, 3. Not enough arguments for format string. Let's see here. Python print integer. Yeah, I guess I won't do the printf stuff. I won't be fancy. I'll just do it this way. Alright, let's see if that does any better. Okay. So this says can only concatenate stir, not float. So hang on. Python concatenate float. So do I need to cast all these just like that? Again, I'm no Python guru, but we're gonna try this and see. Oops. So I guess I'm learning Python at the same time, huh? Oh, oops. There we go. Still not happy. Object has no attribute longitude. Okay, so what I want to do here is we're going to print type event because I want to know what type that is. It is a GNSS measurement. Now, autopilot didn't start. The truck. Oh, okay, it did start. I stand corrected. Look at it go. So I don't have a client. I don't have like a thing up at all. Wow. It hardly even looks like a Cybertruck from up here. Yeah, it's definitely a Cybertruck. Wow. Okay. Cool. I'm going to put the camera back right here so we can see it when I start it up again. So it is a GNSS measurement. That's what I wanted to see. Hang on. So Python carriage return. Okay, so I should be able to just do a /r. Okay, so the problem was this is capitalized when it should not be. Alright, let's yeah. Alright, so I need to clean this up a little bit. I'm going to do tabs here. So hopefully that's a little bit more clear. Yeah, okay. So now I can kind of keep up visually with that. Alright, so it should start moving any moment now. There it goes. Okay, and I do see... Yeah. Okay. So 0, 0, 0 is the center of the map. That means getting the weather is actually, yeah. I can just look for the absolute value of latitude and longitude. Is it stopped? Oh yeah, it is stopped. Wow. There we go, we're moving. Okay, I see the longitude moving. Latitude's now moving. Longitude's really going up there. So longitude is, see, now that's the thing is we can enable autopilot, but can I give it a waypoint, like tell it to specifically go somewhere? That's what I'd like to do. This is awesome. So I'm actually going to leave that running, and I'm going to start looking at how to do the weather thing. So pulling this back over. Where did we see setting the weather? Okay. Okay, so it's just as simple as doing world.set. Now, I don't think world is defined outside of... Ooh, so that's going to be... I wonder if there's a way to set global... I think there is. I'm pretty sure there is. Import CARLA, try... Okay. Self.world, okay. Well... Maybe if I define GNSS listener inside of main, that will work a little bit better. Hi.
Hi.
What's going on?
Going to bed.
You're going to bed? Well, okie dokie. 1 second. There we go. Okay. So I think this should work. I'm actually going to restart this and see if it does. Free variable GNSS referenced before assignment in closing loop. Okay, so. Gotcha. I'll find that here then.
Alexa. Phone 3.
Playing Native American folk music on Amazon Music.
Is that too loud, honey?
Nope. Alright, let's see if this works. Alright, let's see. Alright, it did set the weather. Okay, it set the weather. And it set the weather again. Alright, we accomplished it. So now we spawned in a vehicle, we gave it a GPS sensor, and now as it enters the different coordinates of the map, it changes the weather based on the coordinates it's in. I could attach the sensor to a manually controlled vehicle and, you know, go into the different coordinates myself, but this is good. I mean, we accomplished the goal that we set out to do tonight, so, you know, step by step, we'll eventually get to a point where we'll be doing autonomous driving, and that'll be nice.